Look at the screen here. This person is wondering why gold is used for making jewelry and different metals are used for making machineries or cars. Even if you are wondering why different metals are used and why don't we use gold for making cars? To answer all those questions, today we are going to learn about metals and non-metals. Hello everyone, welcome to Why Thinkers. I am Yashaswini and today we are going to learn about metals and non-metals. So in this chapter, first we will study what are metals, what are non-metals. Then we'll see their properties, their physical properties, chemical properties. And after seeing their physical and chemical properties, we should see how they are going to react. No? So we will see their chemical reactions, how they react with water, oxygen, hydrogen. And after seeing their reactions, they are going to form a product. So what are those products? What are ionic compounds? Now, after understanding all these reactions and all, you'll be wondering, no, where did these metals come from? So we are going to see different processes by which metals are extracted. And to check that we have understood all these concepts clearly, we will solve some previous year questions. So what do we see on the screen? We see a periodic table here. Periodic table is arranged based on atomic number, like increasing order of atomic number. The leftmost part of the periodic table will have metals. And not exactly the rightmost, but the right side of the periodic table will have non-metals. Metals have valencies of 1, 2 or 3 electrons. Valency is the number of electrons in their outermost shell. So let me take an example here. Let's take sodium. Na. Sodium is the metal. What is its atomic number? Its atomic number is 11. So I'll draw the electronic structure. The center part is the nucleus. So in the first shell there can only be 2 electrons. In the second shell there can be 8 electrons. And so first shell has 2 electrons, second shell has 8 electrons, remaining is 1. So 1 electron in its outermost shell. Now this sodium metal is capable of giving away this 1 electron. So whenever it gives away electron, we will call them as cations or electropositive elements. So, we understood metals. Similarly, same like metals, even non-metals have valencies, even they will have some electronic configuration. So non-metals have valency of 5, 6 or 7. Example is chlorine. Chlorine is a non-metal. What is its atomic number? It's 70. So I'll draw the electronic structure for you. So this is the nucleus. The first shell can have only 2 electrons. The second shell will have 8. If you count the number of circles and it is not exactly 8, ignore it, okay? I'm just drawing it here. So in the outermost shell, it will have 7 electrons. So to complete its outermost shell, it is going to take 1 electron. Therefore, they are going to form anions. Whenever you take an electron, you are going to form anions. Whenever you are going to give an electron, you are going to form cations. And we will represent anions with a negative sign, or they are called electronegative elements. So we understood what are metals and non-metals. Let's study different properties of metals. So the first we'll study about physical properties. Physical properties means that we can see, that we can feel, that we can touch. So first physical property is luster. When we see something, it is very shiny and bright, means we will keep seeing. So metals are very shiny and bright. They are very attractive in nature. Like the crown, it is made up of gold. It is very shiny and attractive. Non-metals are very dull looking. They are not attractive. Malleability. So if I take one element and I hit it very hard, it will form one thin layer of sheet. So metals are capable of forming that thin sheet like this. So metals are malleable, non-metals are not malleable. Ductility. I'll take one element, I will draw wires, thin wires. So metals can form those thin wires. They are very ductile. Non-metals cannot form thin wires. Therefore, they are not ductile. Next, conduction of heat. So I'll take one element. I will pass current. So the current, if it moves from one point to another, we say they are good conductors. Same with heat. I'll take one element, I'll start heating. If the temperature from here to here, the heat has transferred means it is a good conductor. So most of the metals are very good conductors of heat, whereas non-metals, they are not good conductors of heat. And however, like we need to know which state they are. No, is it a solid, liquid, or gas? So metals are always solid. They mostly exist in solid state, and non-metals, they can exist as solid, liquid, or gas. Melting and boiling point. So I take something and I start heating. At one point, the solid will become liquid. That temperature at which the solid will become liquid is called melting point. And opposite, when the other state, from liquid to gas, if it is getting converted, we call it boiling point. So melting and boiling point, for metals it is very high, for non-metals it is very low. So these are the major differences between physical properties of metals and non-metals. Ma'am, I understood this. So what next? I understood metals and non-metals. But we are studying chemistry, no? Chemistry means it is all about exceptions. So whatever you studied here, there are exceptions for this. So what are the exceptions? I told that all metals are shiny and bright. But there are some metals which are not shiny and bright, like sodium, potassium, lithium. They're not that shiny looking. And I told all metals are not good looking. Diamond is a non-metal and it is the most attractive thing. All girls will be like, we want diamond, we want diamond. Next, hardness. I told all metals are very good, they're strong, they are in solid state. But there are some metals which are so soft that you can cut it with a knife. Those metals which we can cut it with knife, like sodium, potassium, they're all very soft in nature. And I told non-metals, they are all soft, they are very brittle, they can be easily broken. But diamond is the hardest element that you can find on earth. So diamond is a non-metal, it is an exception for hardness. Next state, I told most of the metals are in solid state, but there are some metals which exist as liquid. For example, mercury. Mercury at room temperature will exist as liquid, though it is a metal. Now, non-metals, they can exist in solid, liquid, or gas, so we are not worried about the state. There is no exception for non-metal here. Now, conductors of heat and electricity. I told all metals are good conductors of heat and electricity. If you have observed the bulb that is shining, there is one coil. It is made up of metal, no? That coil is made up of tungsten, represented as W. It is a very bad conductor of electricity. Though it is a metal, it is a very bad conductor of electricity. For heat also, we have mercury. Mercury is a very bad conductor of heat. Now non-metals, I told all non-metals are bad conductors, but carbon in form of graphite is a very good conductor of heat and electricity. Melting and boiling point, metals have very high melting and boiling point, but exceptions like gallium, cesium have very low melting and boiling point. Non-metals should have low melting and boiling point, but again graphite has high melting and boiling point. Therefore, this is the most important part of this chapter. Why? Because most of the questions, they won't ask you direct difference between metals and non-metals. They are only going to ask you name a non-metal which is shiny, or name the non-metal which has high melting and boiling point. So most of the questions will only come from exceptions. So please make a note of this very carefully. Ma'am, how do I remember this? There is no other option except for either by hearting this or write and practice. Write and practice, that really helps. So, if you have understood this or no, we'll see a question. So, this question was asked for almost 4 years, like in 2015, 13, 12, 10. Now, what is the question here? The question says, name the following a lustrous colored non-metal. You have to say a non-metal which is luster. So, we'll see here. A lustrous non-metal is diamond. So, the answer for the first one is diamond. Next, part B, a metal which melts when, oh sorry, this is melts, okay. There is a typing error, please ignore that. A metal which melts when kept on palm. So as soon as you keep it on the palm, it is melting. That means it should have low melting point. So which are the metals which have low melting point? Gallium and cesium. Any one, or if you name also, you will get full marks. So you can write gallium or cesium. Third, a metal which is a poor conductor of heat. We saw mercury is the poor conductor of heat. Therefore, for third one, we write mercury. So if you write these three names or names of the elements properly, you are going to get 3 markers. Now we understood about the differences between physical properties of metals and non-metals. Let's move forward. Now we will learn about how metals are going to react, their chemical reactions. So before we see how metals are going to react, these metals sometimes they react very violently, like immediately they will react. Sometimes they will not react at all. So based on how they are going to react, we have made a list known as reactivity series. Reactivity series. So this reactivity series is list of metals. They are arranged such a way that the topmost metals or elements that we have written, they are very highly reactive. They are very highly reactive. Now the medium ones, they are moderately reactive. They will react but not too violently, not too softly. They will react easily. So they are going to react moderately. Now the bottom ones, that is especially below hydrogen, whatever elements they are, no, they are very slow. They are almost non-reactive or they are very less reactive. Let me increase the size of the pen for you. Less reactive. So this list, it is a very compulsory list. You have to remember it. If this list, as we go down, the reactivity decreases. What are the elements? Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead. Then comes hydrogen. Hydrogen, why we have put here is hydrogen is neutral. It is not going to easily react. That's why it is neutral. Next, copper, mercury, silver, gold. Ma'am, such big list. How will I remember this? It is going to be difficult. For that, there is a small mnemonic we have come up with. Katrina ne. Katrina stands for potassium K. Katrina ne, sodium. Kar, calcium. Mangi, magnesium. Katrina ne kar mangi. Alto Zen Ferrari. Alto Al aluminium. Zen Zn zinc. Ferrari Fe iron. Alto Zen Ferrari. Fir B. Fir is like lead Pb. B H is highlighted, so hydrogen. Q milli. Q copper. Milli. Mercury is Hg. Silver Od. Silver is silver element. Od Au, we take it as gold. Now this list, if you like, please remember that you have to by heart this list or remember this list in any other form, because this forms the basis of all the reactions for metals with different elements or compounds. So we have understood this. We see which are the most reactive and less reactive. Now we'll see how they are going to react. First, we'll take a metal reacting with an oxygen. When a metal reacts with an oxygen, it will form a metal oxide. Let's take one example. Like sodium reacts with oxygen, it is going to form sodium oxide. Na2O. Sorry, it is not balanced. Let me balance this off. So 4Na reacts with oxygen to give 2Na2O. So most of the metal oxides we have seen in the previous slides and videos that most of the metal oxides, they are going to form basic oxide. Basic oxide means they are very bitter in taste, or their pH value will be very high. Their pH should be greater than 7. Most of the metals will form basic oxides, but there are some metals which will form amphoteric oxide, known as amphoteric. Amphoteric oxide. Amphoteric oxides, like, they are neither basic nor acidic. They can react with both acid or base. Their pH will also be like sort of neutral. Like if they react with a base, they will become basic. If they react with an acid, they'll become acidic. So their pH, like, they are going to react, but their pH will be neutral. They are called amphoteric oxide. Now, I told basic oxide, amphoteric oxide. But how will you know which metal will form basic, which metal will form amphoteric? For that, we'll again come back to reactivity series here. So, in reactivity series, I told that the starting elements are very highly reactive. So, these highly reactive metals, when they react with oxygen, will form basic oxide. Now then we have the moderately reactive elements. These moderately reactive metals, they will form amphoteric oxide. That is, they can react with both acid and base, and they exhibit both acidic and basic properties. Now they both will form basic oxide, amphoteric oxide. But what about these less reactive ones? They will also form oxide, but they will take a lot of time to form oxide. They won't easily react, and they will be forming basic oxides only. Now that is why, see, we are using gold or silver for making jewelry, because though these jewelries are exposed to oxygen too much, they are not going to react easily. Hence, they will remain as gold or silver for very long time. But instead of gold, I use potassium or sodium for making this jewelry. They will instantaneously react and become an oxide. Therefore, these sodium, potassium, calcium and all, they should be stored inside a kerosene solution or any other solution to avoid it from reacting with oxygen. So now we understood what are basic oxide, amphoteric oxide and how different metals form them. Let's solve a question on the same. This question was asked in 2014 for 2 markers. There are going to be questions on how to classify which metal is forming a basic oxide, which metal is forming an amphoteric oxide. Please remember zinc, aluminium, iron and lead. These are the only 4 metals that will form amphoteric oxide. Rest all will form basic oxide. So the first question is, what is meant by amphoteric oxide? Amphoteric oxides are oxides which can react with both bases and acids, or with amphoteric oxides are oxides which will show both acidic and basic nature. Whichever is more comfortable, you can write that. Next, choose the amphoteric oxides among the following. So here, what is the first oxide we see? NaO. Let's go back here. Na is on the top list. It is most reactive. So it is going to form basic oxide. So NaO is not a amphoteric. It is going to form a basic oxide. Next, zinc oxide. Zinc oxide comes in the middle part. It is moderately reactive. So it is going to form amphoteric. Therefore, zinc oxide is amphoteric. Next, carbon dioxide. Carbon is a non-metal, so it is a acidic oxide. It is not a basic oxide. Next, Al2O3, aluminium. We'll again go back, see here. Aluminium comes in the moderately reactive, in the middle section. Therefore, aluminium oxide is also amphoteric in nature. H2O, hydrogen. Hydrogen is neutral. So the oxide that is hydrogen is going to form H2O is also neutral. So Answer should contain zinc oxide and aluminium oxide, and along with the definition of what is amphoteric oxide, you will get complete 2 marks. So remember, the key takeaways to remember is that zinc, aluminium, iron and lead are the ones that is going to form amphoteric oxide, except that all metals are going to form basic oxide. Now let's move forward. Now we'll see how metals are going to react with water. So when a metal reacts with water, it is going to form metal hydroxide and give out hydrogen. So let's take one example. Let me take calcium. Calcium reacts with H2O. It will be forming calcium oxide plus H2. H2 is a gas. So how do we know this is a gas? It will give a pop sound. So hydrogen gas, calcium oxide is a basic oxide. Now if we see in reactivity series, calcium is pretty high, so it is going to react very violently. So whenever this reaction happens, it is highly exothermic in nature and the reaction will be very violent, like immediately it will catch on fire. So all the sodium, potassium, calcium, they are going to react very violently. Calcium oxide and hydrogen gases form. This calcium oxide will immediately combine with water to give calcium hydroxide. That is the second reaction. Calcium oxide combines with water to form calcium hydroxide. Okay, I understood this reaction. So shall I write the same type of reaction for all the metals that I know? No, you can't write that way. Why? Remember, reactivity series, metals will react differently with different uh, compounds and elements. So here, the most reactive ones like potassium and sodium, they will react with cold water only. Like you bring those metals in contact with cold water only, they will catch up fire, they will form oxide and release hydrogen. But calcium, magnesium, they are moderately reactive. So they will require hot water. They will not react with cold water. They will require hot water. Now again, these are aluminium, zinc, iron, they are all moderately reactive. That is why they will require steam. They will not neither react with cold water nor hot water. They will react only with steam. And whichever is below hydrogen, they are least reactive. So they will not react at all with water. Copper will never react with water to form copper oxide or copper hydroxide. Whereas all these under the specification of cold water or hot water or steam, they will react to form oxide and hydroxide. Now we saw that calcium oxide is going to give away hydrogen gas. Therefore, in this reaction, when calcium is added to water and all, we will see that calcium oxide will form bubbles floating. They will be floating on the surface because this hydrogen gas will form bubbles. No, that's why calcium oxide will be floating on the surface. So we saw how all different metals will react with water. So let's see a question on the same. This question was asked in 2022 very recently for 4 markers. Even in your this year paper, you can expect one question on how metals react with water or how hot water, cold water, what is the difference in the reactions and all. So the question here says that we have to do a tabular representation. So the first thing you will do is draw a table. So 3 things: metal, it has to react with cold water, and hot water. So first metal is sodium Na. So Na will react with cold water because Na is very highly reactive. So Na plus H2O will give you Na2O plus H2. Remember, you have to write the balanced reaction and also mention the states and tell that hydrogen is a gas, If you want to impress your teacher a little more, if you want to impress the invigilator a little more, tell that hydrogen gas is identified by pop sound, or there will be bubbles formed when the reaction is happening. Sodium is highly reactive. With cold water only this reaction is happening. So with hot water, same reaction will happen. H2O forming Na2O plus H2. But the oxide that is formed is very unstable. It will immediately dissolve in the hot water to form hydroxide. Again, make sure you have balanced the reaction and write all the things that you can think that you will impress the invigilator with. Now sodium, we have written both the sides. Remember to write 1 or 2 sentences here that this is happening, like sodium reacted with water, hydrogen gas was evolved. We will see effervescence on the top. Sodium will react with hot water, it will form oxide, but that oxide is very unstable. It will again dissolve in the water to form hydroxide. That is sodium. Next, they have given calcium. Ca. Ca reacts with water. It will again form calcium oxide with H2 gas liberated. Same, write the same sentence. And also you can write that calcium oxide that is formed will be floating on the surface because of the hydrogen bubbles. So calcium oxide floats, that you can say. And again, one mistake I did here. I am writing the same calcium oxide, calcium and water reaction in cold water. You have to not write that. Don't make that mistake. Even if you do, realize it and erase it off or strike it out. Say it will not react. Calcium will not react with cold water. Only with hot water it is going to form calcium oxide and hydrogen gas. And here you write that one more sentence, that calcium oxide is going to float on the surface because of hydrogen gas bubbles. Now for magnesium you have to write magnesium is Mg. Again, magnesium is not going to react in cold water. Tell that magnesium will not react in cold water and write the reaction for hot water. MgO plus H2 gas. So this tabular representation along with few sentences will fetch you 4 marks. If you have not written any sentences, ma'am, I had very less time in my exam, I couldn't write the whole sentence. I wrote only the reactions like this. If you are writing it this way, your teacher will only give you 3 marks. Because they are telling you to compare. When they are asking you to compare, it is important that you write 1 or 2 sentences after the reaction to represent it better. So if you write the few sentences, just one sentence, you will get complete full marks. Now we saw how metals are reacting with water. We saw how metals are reacting with oxides. We are clear. And if you have observed carefully, everywhere it is reactivity series. See, here also it was reactivity series. Based on reactivity series only they are reacting. Here also reactivity series. Now same way, next we will see how metals react with dilute acids. Dilute acids are acids which can react, but they are not very concentrated. They will have little amount of water in them. So metal reacts with dilute acid. Let me take an example. Let's take magnesium this time. Magnesium reacts with HCl. HCl is an acid, it is dilute, will form magnesium chloride salt and H2 gas. When magnesium reacts with dilute chloric acid, they are going to form magnesium chloride and H2. There are 3 main mineral acids you have to always remember, that you cannot forget even like after you forget chemistry. That is HCl, hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid. Same reaction will happen with sulfuric acid also. When I write H2SO4, magnesium reacting with H2SO4, it will form MgSO4, magnesium sulfate salt, and hydrogen gas is liberated. But when it comes to nitric acid, metal will not react with nitric acid to form a salt and hydrogen gas, because nitric acid is a very strong oxidizing agent. Oxidizing agent means it will immediately form, like it will immediately add oxygen to one or the other compound. So what happens is magnesium, it will react with HNO3, it should form MgNO3, magnesium nitrate twice plus H2. But since this HNO3 is very good oxidizing agent, it will form, it will make this hydrogen into H2O and form NO2. Therefore, this most of the times metals are not made to react with nitric acid, because it is going to be a very unstable salt that will be formed, and we are going to get oxidized products of hydrogen and nitrogen dioxide. So this reaction is not important. Just remember that metals will not react with nitric acid because nitric acid is a oxidizing agent. So same reactivity series, all the metals on the top, that is like the most reactive metals, will easily react with all the dilute acids. But when it comes to moderate or the medium ones, they will not easily react. So you will need to have like some element like catalyst or anything for the reaction to happen. Here they are reactive. The moderate ones will require a catalyst to happen. But again, those elements which are below hydrogen, they will not react at all. So copper will not react with HCl to form copper chloride, and they will not liberate hydrogen gas because they are less reactive than hydrogen. Now, ma'am, you're telling me that metals will react with dilute acid, they will form a salt. How is the salt getting formed? I wrote magnesium chloride, MgCl2. How did I write it as MgCl2? So let's see how the salt is getting formed here. So we'll take one example. The easiest example is sodium. Its atomic number is 11. So the valency is 1, 2, 8, 1. I will draw the electronic structure of the same. This is the nucleus. 1, 2, and 3. So in the first shell there are 2 electrons. Second shell there are 8. And third shell there is only 1 electron. When sodium reacts with HCl, dilute HCl, it is going to form sodium chloride salt. So the other non-metal part of the sodium chloride is Cl. So we'll take Cl here. Its atomic number is 17. So that is 2, 8, 7. I'm drawing the electronic structure. This is the nucleus. First shell will have 2 electrons. Second will have 8. And third will have 7. Now since this last outermost shell has 7, it will require 1 more electron to complete its structure, and the sodium has 1 extra, so it has to give away this electron. So sodium will give away this electron and chlorine will accept this electron. Sodium is giving away, so sodium is Na plus, Cl is accepting, therefore Cl minus. These two will exchange the electrons, like completely give away electrons or completely take the electron and form NaCl. So these compounds that are formed by giving or taking of electrons, we will call them ionic compounds. So here we saw that there is complete sharing of electrons, like complete giving and taking of electrons. That is why it is ionic compounds. Now, just like metals, non-metals or any compounds, these ionic compounds will also have some properties like physical properties. So always these ionic compounds are solid in nature. Their first property is they are always in solid nature. Now, what about their conductivity? We know metals are good conductors of heat and electricity. Non-metals are bad conductors. Here this compound is formed by both metals and non-metals. So what will happen to their conductivity? In solid state, these compounds are not going to conduct heat and electricity. So if I take sodium chloride salt and I pass electricity, nothing will happen. The electricity will not pass. But the same sodium chloride, if I mix it with water or if it is in molten state, liquid state, then it is going to easily conduct water, because we know water is a culprit in formation of ions. So when water is like, say, if this same with H2O I'll add, then it will be forming ions, Na plus Cl minus ions. Now these ions will conduct electricity. That is why sodium only in its molten state or liquid state is a good conductor of molten or liquid state, is a good conductor of heat and electricity. Of electricity. So till now we understood how metals are going to react with water or dilute acids and how ionic compounds are formed. Let's solve a few questions on the same. This question was asked in 2015 for almost 4 marks. So this was a very important question. The question goes, write the electron dot diagram. The previous slide, when I told you about how the ion is formed, the diagram I have drawn here is the diagrammatic representation of the electronic configuration. But here they are asking electron dot structure. So electron dot structure is, you will not draw the shells and all, only you will draw the number of electrons in the outermost shell with the element name. So they are asking the electron dot structure for chlorine and calcium. Anytime they are asking you to write the electron dot structure or the electronic configuration, they will give you atomic number, you don't have to worry. So first we will take chlorine. So I'll reduce this. Let's write cleanly. So chlorine. Chlorine, they have given it as 17. So it would be 2, 8, 7. That means chlorine will have 7 electrons in its outermost shell. The electron dot structure would be something like this. So 2, 2, 2, 6 electrons on one side and only 1 electron on the other. And the other element is calcium. They have given the atomic number as 20. So it would be 2, 8, 8 and 2. So calcium will have 2 electrons in its outermost shell. So calcium will have the electron dot structure like this. So this is the first step, drawing the electron dot structure for chlorine and calcium. You don't have to write any sentences here, just by writing these things properly like this with the electronic configuration and the dot structure, it is sufficient. Now the second question is, show the formation of calcium chloride by transfer of electrons. This is where you'll have to be careful. See here, calcium has 2 electrons. Chlorine requires only 1 electron. So 1 electron is given here, but there is another electron that should also be given. So what will happen? There will be another chlorine which has only 1 electron, which will take that electron from calcium. So calcium will be giving 2 electrons to 2 chlorine atoms to form calcium chloride. So if you have, when they have asked show the formation, you don't have to do anything. Only thing that you have to do is show that this electron is going here, this electron is going here. Just the arrows will represent the whole thing that is to be written. And by transfer of electrons, there is transfer of electrons, due to which calcium chloride is formed. Now the second part of the question, identify the nature of the above compound. It is an ionic compound. So it is an ionic compound, and they are asking you to write the 3 physical properties of ionic compounds. We have already seen the 3 physical properties. One, it is a solid. The ionic compounds are solid in nature. Second, they have high melting and boiling points. Same like metals, even they have high melting and boiling points. And they will conduct electricity only in molten state. So these three physical properties or any physical properties that you remember, you can write. So if you answer all these parts, 4 marks is completely yours. These come in the case-based section, the last part of your question paper. Now we saw ionic compounds. Now let's move on to the next type of reactions. The next type of reactions is metal reacts with other solutions. Like, let's have a little brief about what we studied in the previous day. We all studied displacement reaction. So in that, what we did, we took one solution like copper sulfate solution, CuSO4 solution, that is aqueous solution we took, and we added iron to it. Fe, iron nail or solid iron. So what happened then? There was a reaction in which we would get FeSO4 solution and copper. So here iron was replacing copper, therefore we named it as displacement reaction. But did you ever think why iron is only replacing copper? Why can't copper replace iron? So what would happen if I react copper with FeSO4? In this case, there would be no reaction. Ma'am, what are you telling me? Your reaction is not happening, their reaction is happening, getting confused. Don't wonder. Again, it is all the play of our favorite reactivity series here. So what is happening is, when in the first case, iron is above copper. See, copper is here, iron is here. So here iron has greater reactivity, or it will react more compared to copper. Therefore, iron is capable of replacing copper. Whereas when the opposite is done, when copper is reacted with ferrous sulfate solution, copper is lower in the reactivity series. Hence, it will not react enough to replace iron. Therefore, it cannot replace and there will be no reaction. So, based on the reactivity series, any metal, when it reacts with a solution, if the other solution has a metal which is in lower order, only then it will undergo a displacement reaction, or else there will be no reaction formed. Okay, we'll just give a little brief about reactivity series. As we come down the reactivity series, the reactivity of the metals will decrease. The topmost ones are the higher, most reactive ones, and the bottom ones are the least reactive ones. So reactivity series is also very important for you guys, because most of the questions will keep repeating on reactivity series. So if you take an average of the 10-15 years paper, every year minimum one question on reactivity series is fixed. It's compulsory. So we'll solve some previous year questions on the same. So this was a question which was asked in 2014, and most of the questions on reactivity series, or most of the questions from metals and non-metals chapter, it will be from 3 marks to 4 marks. Your case-based questions will be from here. So, and like try to remember this chapter better. So the question here is, state what would happen if zinc pieces is placed in blue color copper sulfate solution. So for the first part of the question, it is zinc is placed in copper sulfate solution. So let's have a quick look at the reactivity series. See, zinc is here, copper is here. So zinc is above copper. So zinc is capable of displacing copper in copper sulfate. Therefore, they will undergo a displacement reaction to form zinc sulfate and copper. Now, if you just write this reaction, you are not going to get full marks. What you are supposed to give here, like how much ever concept you know, the way you write the answer, the way you try to impress the invigilator gives you an added advantage on gaining marks. So here also, what you have to write? You have to write that zinc will, when added to copper sulfate solution, will undergo displacement reaction. The word displacement reaction is in way to impress the invigilator. So displacement reaction in which they have given the blue color copper sulfate solution. See, copper sulfate solution was blue, but when zinc sulfate came, the blue color of the solution faded. No, you have to write. It will give the blue color of the solution faded, or it will give faded blue solution. This way, you can say that this is the observation made, or what is happening in that reaction is it is undergoing a displacement reaction due to which the blue color of the solution is getting faded. That should be the sentence for the first one. Now for the second one, what is the second one? They are telling copper pieces are added to green color ferrous sulfate. So the reaction should be copper with ferrous sulfate, FeSO4 solution. So again, let's go see the reactivity series here. Iron is here, copper is below. Copper is less reactive than iron. Therefore, there cannot be any displacement reaction. So you will write that no reaction takes place, or there is no change in the green color solution. That way, you will get the second one correct. The third one is an iron nail is dipped in the solution of copper sulfate for some time. The opposite reaction, iron Fe is dipped in CuSO4 solution. Again, remember CuSO4 is blue in color. So when iron reacts with FeSO4, iron is above Cu, so it is undergoing a displacement reaction. It will form FeSO4 plus Cu. So the blue solution would have turned to faded green solution. Please make sure you write the color change. It is also an added advantage. So if you answer all the 3 questions right, 3 marks is all yours. Scoring marks is important, how much ever we ignore the fact. So we'll take another question here. So this was a question which was asked in 2009 for 5 marks. In 2009, the paper pattern was different where they were asking 5 markers. Now, I know the paper pattern is different, but similar kind of questions, like maybe 1 or 2 questions remote might be asked. That's why we are solving this question. So what is the question? The question says there are 4 metals A, B, C, D and they are added to different solution, iron sulfate, copper sulfate, zinc sulfate and silver nitrate solution. So when added, they have given what will happen if there is a reaction happening, or there is a deposit that is formed, or the reaction is not happening. So wherever there is dash, it means there is no reaction happening, like it cannot react at all. So based on this observation from the table, we have to answer the following questions. So what do we observe from this table? I'll reduce this. So the first question here is, which is the most active metal and why? So when we take atom A, it is not reacting with iron sulfate, it is reacting with copper sulfate. Again, it is not reacting with zinc and silver. So the answer to most of these questions will be in reactivity series. So according to this, there is no reaction with iron, so A is below and it is above copper sulfate. We'll write that off. It is above copper sulfate but below iron, Fe. Now second compound, B. B is reacting with iron sulfate. It is forming a grey deposit. It is not reacting with copper, no reaction with zinc, no reaction with silver. So this means that the compound B must be higher than iron. So we'll write the compound B higher than iron. Next, the metal C is not reacting with any of the 3. That is iron, copper, zinc, but it is reacting with silver. That means it is above silver but below all the 3. So let's put our element C here. Above silver but below copper. The fourth one is like, it's a D, the metal D is not reacting with any of them. So it should be below Ag. Make sure you do this as your side work because this is for your assumption. This will not carry any marks. So once you have done this understanding, we will answer the question. Which is the most active metal and why? So most active metal is the one that is on the top, which is B. And to answer the question why, you have to tell that the metal B is capable of replacing iron. So it is in the list, like in the reactivity series, it is above iron. Therefore, it is the most active metal. That should be your first answer. Now, second, what would be observed if B is added to copper sulfate solution and why? B is above iron, so it is capable of displacing copper sulfate. So you will write that. There will be a displacement reaction. And why there will be a displacement reaction? Because the metal B is on a higher order than compared to copper, so it is more reactive, due to which the green color, the blue color solution of copper sulfate will get faded. That is the answer for the second one. Next, they are asking you to arrange A, B, C, D in the order of increasing order of reactivity. We have already written the order, we have to just write it. So D is the least reactive, then we have C, then we have A, then we have B. This is the increasing order of reactivity. The fourth one, the container of which metal can be used to store zinc sulfate and silver nitrate solution? So if we are like, see, all the zinc sulfate or silver nitrate, they are reactive in nature. If we are storing them, we should store them in such a metal or such a container that they cannot undergo any reaction. So which metal out of the four is not going to react with any of the given solution? D. Yes. The metal D is not going to react. Therefore, the container must be made of metal D. So, if you have a container made of metal D, it will not react with both zinc sulfate and silver nitrate. And the last question, which of the above solutions can be easily stored in a container made up of any of these metals? Like there are A, B, C, D. There are four metals. So, if the container is made of any of these four metals, which solution can you place it inside them without any reaction happening? You can say that zinc iron sulfate, zinc sulfate solution, if you place it in any of the four, zinc sulfate is above here. See, zinc sulfate should be above here. So, zinc sulfate solution, if you place it in any of the four metals, it is not going to react. This type of questions are the places where they test your knowledge. So please be careful when you're writing the answer, when you're logically thinking. If you're using the symbol increasing or decreasing, make sure you're using the right symbol, and please make sure you write the words, important keywords, and one line answers. They are not going to ask you 3 or 4 line answers. All are one line answers. Make sure you're using you're completing that sentence in one line. So if you have answered all these things correct, you are going to get complete 5 marks from this chapter. Now we have understood what are reactivity series, how metals are reacting with different chemicals like oxygen, with oxygen, with water, with dilute acids, with other solutions. We understood all this. This is clear. But ma'am, where is this metals coming from? From where are they preparing these metals? To understand that, now let's study about extraction of metals. Most of the metals exist in their natural form. So in natural form, they exist as minerals. So something like this. These minerals are very crystalline and bright looking. But only some minerals we can extract metals. Not all minerals we can extract metals. So those minerals which will allow us to extract minerals are called ores. Okay, so metals are extracted from their ores. Now, based again, this whole chapter is about reactivity series. In extraction also, it is mostly dependent on reactivity series. So, based on the ore, like the metal inside the ore, we can do the process of extraction. So, here also, the highest ones, the most reactive metals, the ores of these most reactive metals are very difficult to extract. Like, it is very difficult to undergo extraction. Therefore, we will do electrolysis for extraction of most reactive metals. Now then we have the moderate ones, like, the most reactive ones we usually consider only potassium and calcium, potassium and sodium. So all the other ones are moderate ones. So all the other moderately reactive ones, we will, there are two ways that ores are present. Either it will be a carbonate ore. So these metals will react with carbonate, and there would be a carbonate compound, or there might be a sulfide compound. This metals would have reacted with sulfur, and there would be a sulfide compound. So based on whether it is a carbonate or a sulfide, if it is a carbonate, we will do calcination process, CALCINATION, calcination process. Or if it is a sulfide ore, we will do roasting. This calcination and roasting is done only to reduce this carbonate or sulfide to an oxide. We will reduce it to an oxide, and once we reduce it to an oxide, we will do reduction process to get the pure metal. So if they are most reactive metals, we will directly do electrolysis. If they are moderately reactive, then we will get the ores. If it is a carbonate ore or a sulfide ore, if it is a carbonate ore, we will do calcination. Sulfide ore, we will do roasting. And after we do calcination and roasting, we will get an oxide, which we will do reduction to get the pure metal. And as told, the lower ones, they are naturally available. They are pure substances. They are available in their pure form. They are not available as minerals or ores. They are available in their pure form. Gold, silver, they are directly mined. There is no extraction process that is done. Directly under mining, we will get gold or silver extracted. So we will learn each of these processes in detail. The first process is electrolysis. So electrolysis is done for sodium or potassium. So what happens is, there will be one bath which will have the ore solution. Ore solution is like the sodium ore. If it is a sodium ore, it will have sodium ore solution or potassium ore solution. Then there will be two anode. There will be a one cathode and anode that will be placed, which will have conducting electricity. So when they pass current electricity through this, what will happen? This ore will form Na plus ions and Cl minus ions. So these Na plus ions will go to cathode and form sodium metal. This Na minus ions will go to anode and will give chlorine gas. Okay, this is the way sodium is extracted in its pure form. This process of extraction is called electrolysis. So for most reactive metals, we will undergo electrolysis. So this is clear. Now, this is, wait, I'll just name it as electrolysis. Now, we'll go to the moderate ones. So moderate ones, they either exist as carbonate or sulfide. Let's take the middle one, like zinc. So zinc in its ore form would exist as zinc carbonate. Sorry. It will be ZnCO3. So in the process of calcination, calcination is the process of converting the carbonate ore, this is the ore, to oxide. So what we will do, we will heat this compound and we will get zinc oxide plus carbon dioxide gas. This is the oxide that we are looking for. Now this process by which we are converting the ore to oxide is called, if it is a carbonate ore, we call it as calcination. The first step is done. If it is not a carbonate ore, it is a sulfide ore, then what to do, ma'am? In sulfide ore also, we are going to either heat it, or we might even react it with other compounds which are capable of giving the heat. So we'll take the ore, we will heat it in presence of oxygen. So I'll write that here. This sulfide, so sulfide ore, in presence of oxygen we will heat it. So we will get zinc oxide plus sulfur dioxide gas. We got the oxide. The process in which we are converting the sulfide ore to oxide, we call it as roasting. So two ways we can convert the given ore to oxide. The first is calcination, that is any carbonate ore, we are going to heat it in presence of limited amount of oxygen. There won't be too much of oxygen, so that we will get zinc oxide and carbon dioxide. That is called calcination. The sulfide ore in maximum present, like in more amount of oxygen, we are going to heat it to get oxide and sulfur dioxide. This process is called roasting. So now we got oxides. We got the oxide through calcination and roasting. Now we have to convert these oxides or reduce these oxides to get the pure metal. So what we will do? We will do reduction. In the previous, in one of the first initial chapters, we have studied about what is a redox reaction, how reduction happens, but here we will study again in deeper. So what we'll take zinc oxide, and we will make sure the zinc oxide reacts with other, it could be a non-metal or any reducing agent. So for zinc oxide, we'll take carbon. Carbon is a reducing agent, and we will get zinc plus carbon monoxide. This way we are going to get our pure metal from the ore. Now in reduction, there is no necessary condition that we should use only carbon. We could use other metals. Say for example, if it was ferrous oxide. So ferrous oxide, it would be a sulfide ore. So I did roasting, I did everything, I got Fe2O3. Ferrous oxide. Now I have to reduce this oxide to get the pure metal. So here I can use aluminium. Again, remember aluminium is in a higher order than iron. So aluminium is capable of displacing iron, and here it is undergoing reduction. Aluminium is the reducing agent, due to which we will get Al2O3 and iron. This way we are getting the pure metal, and this process is also known as thermite welding. Why this process is called thermite welding is, if you have seen in your, like whenever they are doing some iron works, if there are two iron metals, to join them there will be some other solution that will be added and heated at a very high temperature. This other solution that is added, other metal that is added, is the aluminium, which will replace iron and form the joint between the two iron rods. This process is called thermite welding. So now we have understood electrolysis, that is how highly reactive metals are extracted. Then we understood calcination, roasting and reduction. All these three steps under one is for moderately reactive metals. Moderately reactive metals we have extracted, and the pure substances like silver, silver, gold, they are extracted directly from their ores. They are mined directly from their ores. We have understood all this. Now, if you see here, the iron that is obtained here or the zinc that is obtained, it is after a reaction. So there might be a possibility that these are impure. They might contain some impure substances along with the metal. So what to do? We have to refine them. We have to get a pure metal. So to get the pure metal, we are going to do another process known as refining. So whatever metal we are going to get, no, in the previous slides, like through roasting or reduction and everything. So we will take that metal and we will do electrolysis. So this anode will be your impure metal. So let's take zinc only. So zinc, whatever was prepared, that impure metal I have taken here, and this I have connected to current, and there will be a moderator solution here. So this impure metal, when current is passed through it, what will happen? All the ions that is going to be present will form a solid mass here. They will just drop down here, and those impurities we call it as anode mud. And the pure metal that we are hoping to get, like zinc, will go and get attached at the cathode as pure metal. So this is a process of refining the impure metal through electrolysis. So when current is passed, the pure metal will go and get attached, will go and form at the cathode as zinc, and all the other impurities drop down as anode mud. This is the process by which we are going to get pure metals. So till here we have understood how is the extraction process done and how to obtain the pure metal from the extracted metal. So we'll see a few questions on the same. This was a question which was asked in 2015 for 5 markers. Again, the question paper pattern has changed. There won't be any 5 marker question, but a very similar question which is case based might be asked in your exam. So let's solve this question. The first part of the question says, what type of ores are calcined? We learned in the one of the previous slides that, see here, carbonate ores are the ones that will undergo calcination process. Therefore, we will write the answer as calcination. So there are only carbonate ores are calcined. We will write the answer as carbonate. So they're asking an example. Let's take an example. The one example that we have already studied is zinc carbonate, ZnCO3. So what we will do, we will heat it to get zinc oxide plus carbon dioxide. This is the reaction that you have to write. This reaction answers the first part of the question. The second part of the question goes, in what form calcined ore is obtained? We are going to obtain the calcined ore in form of an oxide. Make sure you write the word oxide. That will gain you the mark. And how it can be reduced? Give the chemical equation for reduction process involved for the example given by you. We have given the example of zinc carbonate, so we should give the reduction process for the same. So what we will do, we will take zinc oxide and we have to reduce it. So what is the reducing agent we used? We used carbon as the reducing agent, through which we got zinc plus carbon monoxide. So we got the pure metal. Now name any two metals used as reducing agent by displacing metals of lower reactivity. Always remember, if there is displacing metals or displacement reaction should occur, means only higher reactivity metals can be used. So the most reactive metals like sodium, potassium, aluminium, they can be used as reducing agent. So all the three answers with a little bit of sentence will fetch you the full 5 mark. Now we'll solve another question. This was a question which was asked for 2 years, again for 4 marks. This is almost similar to the pattern that you are going to face. So here a metal E is stored in kerosene. Remember in the first, when we studied reactivity series, only the most reactive metals are stored in kerosene. So the most reactive metals are sodium and potassium. So it is either of them. When the small piece of this, the storage container is left open, they are going to react, they are going to catch fire. So sodium or potassium, when left open in the presence of oxygen, what will happen? This sodium will react with oxygen to form Na2O. So first write this reaction for the formation of the oxide. Now when the given product that is going to be formed, that is sodium oxide, it is dissolved in water, it turns red litmus blue. So this sodium oxide Na2O is dissolved in water H2O to give NaOH. Now NaOH is a basic solution, therefore it is turning the red litmus blue. So the metal, name the metal E, you can write the metal E as either sodium or potassium, whichever is comfortable. Write the chemical equation for reaction when it is exposed to air and when the product is formed. Always make sure you write the balanced chemical reaction along with the states. So here sodium reacts with oxygen giving sodium oxide, and sodium oxide in water will give the basic hydroxide, NaOH. Now explain the process by which metal is obtained from its molten chloride. So the metal we have taken here is sodium, and we have to explain how this sodium is extracted from its molten form. So because sodium is one of the most reactive metals, we are extracting it through electrolysis. So you have to write the word electrolysis because that is the process that is happening. So a pictorial representation always is an advantage to impress the invigilator. So we will take the ore solution. Here in the bath there is cathode, anode. When a current is passed, Na plus and Cl minus ions, Na plus will go to cathode, Cl minus will come out as chlorine gas. So this you have to represent through equation also, like Na plus will go to cathode become Na, Cl minus will go to anode will become Cl2. Make sure you write this in 2 or 3 sentences explaining what is the process happening. There is a whole solution taken, it is dipped inside an electrode and the current is passed. Sodium ions move to cathode and we'll get the pure metal, and chlorine will move to anode and we'll get chlorine gas. This full sentences along with the equation will fetch you 4 marks. So till now we have studied about extraction of metals and we have solved some previous year questions. Make sure you are completely clear about extraction of metals because one fixed question on extraction will be there in your paper. Next, we'll learn about metals we have studied completely. Now we'll see what is corrosion and what happens to metals when they are corroded. So corrosion. So let's take one metal. I'll take zinc. Okay, when this zinc metal, I leave it in the open air, what will happen? It will react with oxygen and it will form zinc oxide. Zinc metal in its elemental form, it was very hard, solid and it had very good strength. But zinc, when it forms zinc oxide, it is a compound and it will not have the same strength as the pure metal. Therefore, the strength of the metal is decreasing because of the formation of oxide, and this process is called as rusting. So rusting is the process by which a metal reacts with oxygen to form a compound due to which the strength of the metal decreases. Now once this rusting is formed, what happens with zinc is only zinc oxide will form and it will stop. But in case of iron, Fe plus O2 will give Fe2O3. Again, it is undergoing the process of rusting but the strength of the iron will get reduced to such an extent that it will undergo corrosion, that the metal will decompose completely and it will break. So to avoid that, we will do prevention. So what are the prevention techniques to avoid corrosion is, first method is galvanization. So galvanization, it is a process by which we will coat this iron metal, we'll paint the iron with some other metal like zinc or magnesium. We will paint the iron metal with the other paint so that only the zinc or magnesium will get oxidized and iron will not get oxidized. This is the first step. The second step is to keep out of water or oxygen. So these two ways, like if there is no oxygen, how will the metal get corroded? So you can always keep it in an environment where it is not humid and then there is no more amount of oxygen. So this way we can prevent corrosion. And now we will see a quick overview of what we have studied in this video. To summarize this chapter, we first started with why metals are important or what are the properties that we need to know about metals. So we started here, we studied about different properties of metals and non-metals, and here we saw the exceptions, which metals and non-metals show exceptions. Please remember this table very well because your questions are only coming from this here. Next, we came to the reactivity series, that is the chemical properties, how metals react with different chemicals like oxygen, water, or with other solutions, or with dilute acid. What are the properties these metals show when they react with them? So we studied that. And for remembering the reactivity series, we came up with a mnemonic. If you can remember it with the same mnemonic, please go ahead, or else at least try to by heart the reactivity series. And after we have understood the reactivity series, we saw with oxygen how it is reacting, with water how it is reacting, with dilute acids how it is reacting, and then we saw the formation of ionic compounds by sharing of electrons, how the metals will give away electrons and how chlorine will take electrons to form ionic compounds. We saw the properties of ionic compounds. Then we saw the displacement reaction, the metals will go according to the reactivity series. Then we came to the main part, extraction of metals, how the highly reactive metals are extracted through electrolysis. We studied electrolysis process in deep. Then we studied the moderately reactive metals, how they are extracted from their ores like carbonate ores or sulfide ores. Carbonate ores are calcinated and sulfide ores are roasted, and then they are reduced to get the pure metal. And the lower reactive metals, they are obtained in their pure substance, they are available in their pure form. And after this, we also saw that they have to be refined to obtain the pure form, so we did electrolysis for refining them. And with this, we solved previous year questions also to check how much we have understood. So this chapter is a very important chapter in your exam paper, and there will be at least one question on extraction and reactivity series. Please go through the video again if you have not understood that concept, and for more such content, please subscribe to Why Thinkers.